Hello everyone, section 3.3, polynomial division and synthetic division. So long division is what we're going to do on this particular problem. We're going to divide this polynomial by this polynomial. We're going to do it using long division. We're not going to do synthetic division just yet. The reason being is that there are times when you can't use synthetic division. You can only use synthetic division in certain instances. So let's set up x minus 2 on the outside, 6x cubed minus 19x squared plus 16x minus 4. I don't need any placeholders. 3, 2, 1, 0. Divided by. Alright, what do we multiply x by to get 6x cubed? We got to multiply it by 6x squared. So 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. Now I'd put it in parentheses and put a subtraction on the outside. Some teachers do it differently. I just like to do that this way. This way I remember that have to change the sign over here. 6x cubed minus 6x cubed, those are gone. Negative 19x squared minus a negative 12x squared is negative 19x squared plus a 12x squared becomes minus 7x squared. Carry down the 16x. What do we multiply x by to get negative 7x squared? We multiply by negative 7x. Negative 7x times x, negative 7x squared. Negative 7x times negative 2 gives me plus 14x. Again, I like to put it in parentheses so that I remember negative 7x squared minus a negative 7x squared, those are canceling. 16x minus the 14x is 2x. Bring down the minus 4. What do we multiply x by to get 2x? 2. Distribute 2x minus 4. Subtract it. We have a remainder of 0, which means that 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2 equals 6x squared plus 7x plus 2. Okay. Example 2, we're going to do the same thing. This time we are going to need some placeholders. So we've got x minus 1 on the outside, x cubed plus 0x squared plus 0x minus 1. Multiply by x squared. Distribute. So x squared minus x cubed, sorry, minus x squared. Those cancel. 0x squared minus a negative becomes plus x squared. Multiply by x. X times x. Carry down the plus 0x. X times x is x squared. X times negative 1 minus x. Put in parentheses. 0 plus x. Bring down the minus 1. Multiply by 1. X minus 1. I get a remainder of 0 again. So that means that x cubed minus 1 over x minus 1 equals x squared plus x plus 1. This should make sense if you remember SOAP. X cubed factors into the binomial and the trinomial. What do you cube to get x cubed? X. What do you cube to get 1? 1. SOAP, same. Square. Multiply them together. Square. Same. Opposite. Always positive. Same result. This times this is this. Multiply that, x minus 1 on both sides, we get the exact same statement. Alright, so that was example 2. Example 3 is an example where the reason that I'm showing you long division is because synthetic division doesn't apply to this problem. We wouldn't be able to use synthetic division even if I wanted to in this problem, because synthetic division is only used when we're dividing by something in the form of x minus k, like we had x minus 1 in the previous example, or in the example before that we had x minus 2. K would be 1 or 2. In this one, what I'm dividing by is something quadratic, so not a linear. So I wouldn't be able to divide by it. And not just linear, it's got to be linear with lead coefficient as 1. Okay, so long division. X squared plus 2x minus 3. And then 4, 3, 2, 1, 0. We don't need any placeholders. 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. What do we have to multiply x squared by to get 2x to the 4th? We're going to multiply by 2x squared. That's going to give me 4x squared, square at 4th, sorry. And 2x squared times 2x is going to be 4x cubed. 2x squared times a negative 3 is minus 6x squared. Minus, oh, I put the 4 in the wrong place. That's what confused me. That's a 2. Alrighty. Cancel. Cancel. Negative 5x squared minus a negative 6x squared is plus a 6x squared. So x squared plus 3x minus 2. What do we multiply x squared by to get x squared? Nothing. So what do we do at this point? This is the remainder. I can't go any further with that. Sorry. Or what do I multiply x squared by to get x squared? 1. Plus 1. So 1 times x squared, so I get x squared plus 2x minus 3. In parentheses, subtract it, cancel. 3x minus 2x is x. Negative 2 minus a negative 3, or negative 2 plus 3 plus 1. This is my remainder, because there's nothing I can multiply x squared by to get x. This is a smaller degree. This is my remainder. So how do we write that? So we have the original polynomial, 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 equals 2x squared plus 1, 2x squared plus 1, plus the remainder over what we're dividing by. X plus 1 over x squared plus 2x minus 3. And that's our final answer. It also means that this is not a factor of this. Okay. Synthetic division is a quicker version of the division. It's incredibly useful when we're dealing with a linear factor whose lead coefficient is a 1. Then we can set up our synthetic division. So we're checking to see if negative 3 is a 0. For 3, 2, 1, 0, we're going to need a placeholder. So we take the coefficients, including the placeholder, right? Because this is really x to the 4th plus 0x cubed minus 10x squared minus 2x plus 4. So we need this placeholder. 1, 0, negative 10, negative 2, positive 4. I don't know why I'm writing the positive. Just 4. Turn that over. Bring it down. First term comes down. Negative 3 times 1, negative 3. 0 plus negative 3, negative 3. Negative 3 times negative 3, positive 9. Add these together. Negative 1, positive 3. Add these together. 1, negative 3, 1. We have a remainder. That's okay. This becomes, well, the original function, x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3 equals, this was x to the 4th, this is x cubed minus 3x squared minus x plus 1 plus the remainder plus 1 over what we're dividing by, x plus 3. Note: what is f of negative 3 in this function? So putting negative 3 into this function. Negative 3 to the 4th minus 10 times negative 3 squared minus 2 times negative 3 plus 4. Negative 3 to the 4th is positive 81. Negative 3 squared is 9 times the negative 10 is minus 90 plus 6 plus 4. 81 minus 90 is negative 9 plus 6 plus 4. Negative 9 plus 6 is negative 3 plus 4 is 1. So f of negative 3 equals 1. This is not a coincidence, which leads us into the remainder theorem. If a polynomial f of x is divided by x minus k, something that we can use synthetic division on, then the remainder r is equal to f of k. Take this value, put it into the function, you're going to get out what the remainder is. So we're going to use the remainder theorem to evaluate the following function at x equals negative 2. In other words, we're going to find f of negative 2. F of negative 2 equals some question mark. Use synthetic division to do it. So we're going to put negative 2 into the box. 3, 2, 1, 0. We don't need any placeholders. So 3, 8, 5, negative 7. Whatever this is going over here. Bring down the 3. Negative 6, 2. Negative 4, 1. Negative 2, negative 9. F of negative 2, we now know, equals 9. The remainder theorem. Pretty easy, straightforward. All right. Show that x minus 2 and x plus 3 are factors of this long polynomial, a polynomial that we wouldn't be able to factor directly. So these are linear factors, lead coefficients 1 on both of them. I'm going to use synthetic division 2 times. Each time that I use synthetic division, if I get a 0 for a remainder, then it's a factor of the polynomial, or also a 0 for the polynomial. So let's do the negative 2, the 2 first. 4, 3, 2, 1, 0. We don't need any placeholders, so 2, 7, negative 4, negative 27, negative 18. Hoping to get a 0 here. If I get a 0 here, I have shown that x minus 2 is a factor. Carry down the 2. 4, 11, 22, 18. 2 times 18, 20, 36. 36, 9. 2 times 9 is 18. 0. We've just shown that x minus 2 is a factor of the polynomial. Now, to do x plus 3, I don't have to go back to the original. Too much work. Go to the reduced function. We're testing negative 3 now. We're hoping to get a 0 here. Bring down the 2. Negative 6, 5. Negative 15, 3. Negative 9, 0. Ding, ding, ding. We have just shown that x minus 2 and x minus 3 are factors of this polynomial. I'm going to take it one step beyond what the question's asking. The question leads us now with this. 2x squared plus 5x plus 3. Does this factor any further? It's quadratic. Once you get it down to quadratic, try to factor it. If you can't factor it, go to the completing the square or the quadratic formula. I don't think we need the quadratic formula on this one. I believe we can factor this one without the quadratic formula. 2x plus 3x plus 1, 2x, 3x, 5x. There are our remaining 2 factors and zeros of this function. So f of x equals x minus 2, x plus 3, 2x plus 3, and x plus 1. It is now completely factored. You have some IXL work, and there's your bookwork. Thank you very much. Bye.